Chapter 11, we're still on counting methods and probability theory, and in this section, we're going to look at events involving not and or, and we're also going to look at odds. Objectives: find the probability that an event will not occur, find the probability of one event or a second event occurring, understand and use odds. The probability of an event not occurring. The complement of E. If we know the probability of E, the probability of an event E, we can determine the probability that the event will not occur, which is denoted by P not E. The probability that an event E will not occur is equal to 1 minus the probability that it will occur. The probability that an event E will occur is equal to 1 minus the probability that it will not occur. Using set notation, if E with the asterisk, which is read complement of E, then the probability of not E is equal to 1 minus probability of E, and probability of E is equal to 1 minus probability of not E. Example 1, the probability of an event not occurring. If you are dealt one card from a standard 52 card deck, find the probability that you are not dealt a queen. Because the probability of not E is equal to 1 minus the probability of E, we're going to find the probability of not E equals 1 minus probability of queen. On the right side of this, we have 1 minus 1 over 13. One is equal to 13 over 13. We want to write that way so that we can subtract the 1 over 13 from it, and that gives us 12 over 13. So the probability of not a queen would be 12 over 13. Or probabilities with mutually exclusive events. Mutually exclusive events. Events A and B are mutually exclusive if it is impossible for them to occur at the same time. Or probabilities with mutually exclusive events. If A and B are mutually exclusive events, then the probability of A or B is the probability of the two separate probabilities added together. Using set notation, the probability of A union B is equal to probability of A plus probability of B. The probability of either of two mutually exclusive events occurring. If one card is randomly selected from a deck of cards, what is the probability of selecting a king or a queen? The probability of a king or a queen, because that's mutually exclusive, would be probability of king plus probability of queen. That would be 4, because there's 4 kings in a deck, over 52, plus 4 queens over 52, which would be 8 over 52, and we remember to reduce it to 2/13. Or probability with events that are not mutually exclusive. If A and B are not mutually exclusive events, then the probability that A or B will occur is determined by adding their individual probabilities and then subtracting the probability that A and B occur simultaneously. And you can see this written two different ways. The bottom part is using set notation, which is probability of A union B is equal to probability of A plus probability of B minus probability of A intersect B. Example 3, and or probability with events are not mutually exclusive. In a group of 25 baboons, 18 enjoy grooming their neighbors, 16 enjoy screeching wildly, while 10 enjoy doing both. If one baboon is selected at random, find the probability that it enjoys grooming its neighbors or screeching wildly. Here's the solution. Since 10 of the baboons enjoy both grooming their neighbors and screeching wildly, these events are not mutually exclusive. So the probability of grooming or screeching is equal to the probability of grooming plus the probability of screeching minus the probability of grooming, and screeching. And then under these, we have their numeric values. For the probability of grooming, 18 of the 25 baboons enjoy grooming, screeching, 16 of the 25 enjoy screeching, and for grooming and screeching, 10 of the 25 enjoy both. So we're working with fractions. 18 plus 16 minus 10 is 24 over 25, and that cannot be reduced. Probability to odds. If we know the probability of an event, we can determine the odds in favor or the odds against the event. Number one, the odds in favor of E are found by taking the probability that E will occur and dividing by the probability that E will not occur. The odds against E are found by taking the probability that E will not occur and dividing by the probability that E will occur. The odds against E can also be found by reversing the ratio, representing the odds in favor of E. Example 4, from probability to odds. You roll a single six-sided die. Find the odds in favor of rolling a 2. So we're going to let E represent the event of rolling a 2. Find the probability of E occurring and the probability of E not occurring. The sample is the 6, including 1 through 6. E is the event of rolling a 2. The probability of E would be 1 out of 6 because there's only 1 2 on a single die. The probability of not E would be 1 minus 1/6, which is 5/6. So the probability of E divided by the probability of not E is equal to 1/6 divided by 5/6. Remember, to do this, we have 1/6 times the inverse of 5/6, which would be 6 over 5. Canceling out the 6's, we get 1/5. Odds to probability. If the odds in favor of event E are A to B, then the probability of the event are given by probability of E is equal to A over A plus B. Example 5, the odds in favor of a particular horse winning a race are 2 to 5. What is the probability this horse will win the race? Solution, because odds in favor, A to B, means a probability of A over A plus B, then the odds in favor, 2 to 5, means a probability of 2 over 2 plus 5, which is equal to 2 over 7. The probability that this horse will win the race is 2 over 7. And that concludes this lesson.